Welcome fellow explorers to Project Makirraji. Last episode we saw how 6 pioneers developed the adaptations needed to colonize dry land. In this episode we will see how these creatures diversify to fill out the ecosystems of their respective continents. We start our exploration on the continent of Kaiora. Here the first land-dwelling organisms were the Terrestrial. These organisms, which I will henceforth refer to as plants, quickly spread across the continent. However, as these plants grow and die, they leave behind their bodies. At this time land lacked any decomposers, which may lead to a build-up of dead plant bodies. As these plant bodies build up, one clade of Terrestrial may begin to feed on these bodies. Over time they may specialize for this lifestyle until they are completely reliant on the dead bodies of other organisms to survive. This lifestyle may be so effective that they lose the ability to photosynthesize and thus lose their color. We'll call these decomposers the Morategro. Yet other Terrestrial may develop a different body plan. As the Terrestrial spread across the continent, interspecies competition may rise. One clade may grow taller with a wider base for better access to sunlight. They may develop a larger leaf surface to consume as much light as possible. These adaptations will allow these plants to become the dominant form of vegetation on Kaiora. Along with the Terrestrial, these plants make up a group called the Xelophytes. We'll call this clade the Xelophygro. The Xelophygro, along with the Terrestrial and the Morategro, will create the base of Kaiora's terrestrial ecosystems. Soon after these clades evolve, the Pineri will make landfall. With no predators and essentially unlimited food, it is inevitable that the Pineri will undergo an adaptive radiation. An adaptive radiation is an event in which a species arrives in an uncolonized environment and quickly evolves to fill as many niches as possible. The aselective tendencies of the Pineri will help them spread across the continent. Aselective species tend to be smaller with more generalist lifestyles, which lends them to colonizing new habitats. A clade of Pineri may become even smaller than they already are. Their small size means they don't weigh much at all. This suits the creature's hydrostatic skeleton, seeing as it doesn't allow for extremely large sizes, but is quite effective at smaller scales. These miniature Pineri are analogous to the arthropods of Earth, more specifically insects. Their small size and adaptive tendencies may allow them to achieve staggering levels of diversity. Habitat variation is much more extreme at smaller scales, which may influence these creatures' diversity. This group will be called the Mulariforms. Although it would be practically impossible to visualize the entirety of these creatures' diversity, we can still identify some of the major groups among them. Some herbivorous groups may develop sharp protrusions from their tentacles, allowing them to slice through plant matter. Others may develop broader, more muscular tentacles to dig into the tougher exterior of the plant. Still others may develop sharp spines at the ends of their tentacles used to pierce a hole in the plant body. They then use their proboscis-like mouth to suck up the plant's fluids. The emergence of these herbivorous clades gives other Mulariforms the opportunity to feed on them. Some may evolve to feed upon the decomposing bodies of animals and plants, assisting the Morategro in keeping the grounds clean. Others may evolve longer tentacles and legs. Their longer tentacles entangle the prey and bring it to the mouth, while the long legs aid in maneuverability and help them see over obstacles. Yet others may evolve massive teeth to crush and rip apart prey. The mulariform's diversity will span far beyond the groups outlined here. Nevertheless, they will spread across the continent, forming the base of most all terrestrial ecosystems and in turn allowing for more complex forms to evolve. One group of Pinnarii may take the opposite approach to the mulariforms, gigantism. Despite the constraints imposed by their hydrostatic skeleton, these Pinnarii may manage to evolve into the largest terrestrial creatures yet seen on Makirraji. Their exceptional growth can be attributed to several factors. A diet rich in the abundant vegetation of their environment provides them the necessary nutrients for sustained development. Moreover, their increased size may coincide with a shift in reproductive strategy. From the rapid, prolific R-selection of their smaller ancestors, these larger forms may adopt K-selection, characterized by fewer offspring but greater parental investment. This strategy is common among larger species with longer lifespans, as it ensures the survival of a smaller number of well-equipped individuals. K-selection in these Pinnarii may mean producing only 20 to 40 eggs at a time. This reduced brood size allowed for more intensive care of each offspring, increasing their chances of survival in a competitive environment. We'll call this group the Volumae. As these larger forms evolve, it is inevitable that predators will emerge to exploit them as a food source. One potential evolutionary path for a clade of Pinnarii involves the development of sharp, needle-like teeth. This adaptation would allow them to capture prey more effectively and masticate it for digestion. In addition, their legs might become more muscular, enhancing their ability to pursue prey. To navigate through dense vegetation, they might also develop a longer, more flexible body. This adaptation could increase their overall speed, as they would be able to use more of their body in running. While these adaptations could potentially allow Pinnarii to achieve short bursts of speed, they may still rely heavily on ambush hunting. This is because their hydraulic skeleton might limit their ability to sustain extremely fast locomotion over extended periods. Furthermore, their eyes might cluster together, giving them a narrower yet more precise field of view. This would allow them to lock onto prey during pursuits. We'll call these predators the Tentacuta. The Nymphas may hold dominion over Kaiora for thousands of years before the arrival of the Sequidata. However, once the Sequidata do arrive, it will throw Kaiora's ecosystems into chaos. As the Sequidants spread across the continent, they will come into competition with clades such as the Tentacuta. However, the Sequidants possess a considerable advantage with their skeleton, which will increase their maneuverability and allow them to grow to much larger sizes. Once the Sequidants take up residence on land, they may diverge into two distinct clades. One clade may have a leg that has 3 joints in the leg. One connects to the main body, the other is the knee of these creatures, and the final joint would connect to the foot. The feet of these creatures would be without digits. The toes of tetrapods evolved from the bones in their fins. These creatures, however, may not have a skeletal structure that could incorporate any digits. The 3 joints of these creatures would give them a more rigid range of motion, but it would also allow them to reach larger sizes. We'll call this clade the Diviodonta. The other clade may possess 4 joints in the leg, one to the main body, one to a knee, one to a smaller joint near the foot, and one for the foot itself. This configuration would grant these creatures high flexibility and maneuverability. This means they would likely be extremely adaptable. We'll call this clade the Termelodonta. Once these clades evolve, they will be in immediate competition with the Nymphas. Generally speaking, no two clades can inhabit the same niche without competing, which ultimately results in one outcompeting the other. The Neropods' lack of an internal skeleton means they can't achieve nearly the same level of speed, size, or maneuverability as the sequidants. The Termelodonts with their maneuverable skeleton may be able to effectively compete with the Tentacuta. The predatory Termelodonts may adapt for pursuit hunting. Their hind two pairs of legs may become flat against the body, allowing for a more directional application of force. One of the frontmost pairs of legs may be used in turning, allowing them to execute sharp turns while running. The three remaining pairs of legs will mainly be used for support when not running. Their eyes will be rotated to face forward instead of around the body. Although this decreases their field of view, it does have the benefit on increased depth perception. Their bottom two tentacles may develop serrated teeth used to slice their prey. We'll call them the seadance. The seadance may be such effective predators that they completely outcompete the Tentacuta, eventually driving them to extinction. While many Termelodonts remain specialized predators, some may evolve to be more versatile scavengers. These adaptable creatures may expand their dietary preferences to include a wider range of organisms, such as the mulariforms, and even the carcasses of other animals. To supplement their protein intake, they may also consume plant matter. One of the most notable adaptations in these generalist Termelodonts is the elongation and increased sensitivity of their bottom tentacle. This specialized appendage, covered in sensory hairs, allows them to probe the leaf litter and locate hidden prey such as mulariforms. The top two tentacles, equipped with sharp teeth, serve as efficient tools for masticating their food. To accommodate their expanded diet and ensure stability while tearing into flesh, these Termelodonts have developed a wider stance than their more specialized relatives. This postural adjustment provides a solid foundation for exerting force and efficiently consuming a variety of food sources. We'll call this group the Odentodonts. As the Termelodonts diversify, so too will the Deviodonts. The Deviodont skeletal structure, characterized by their three-jointed legs, may provide a foundation for larger body sizes. Compared to the Termelodonts, their legs may exhibit a more restricted range of motion, granting greater stability while restricting agility. Given these factors, it's plausible that some Deviodonts could evolve into larger herbivores. On Earth, large herbivores often possess specific adaptations that enable them to reach such substantial sizes. However, Makirraji's slightly larger size and stronger gravitational pull compared to Earth would present unique challenges for terrestrial animals. While aquatic creatures in Makirraji's oceans might be less affected by gravity due to the water's buoyancy, land-dwelling animals would likely face significant constraints. To accommodate larger body sizes, Deviodonts could develop adaptations such as thicker, denser bones for increased structural support. One particularly intriguing response to Makirraji's extreme gravity might be the specialization of their tentacles. On Earth, large animals often grow to larger sizes for at least one of three reasons: to reach taller vegetation, deter predators, or capture large prey. The Deviodonts might evolve a similar strategy, aiming to access the foliage atop the tallest trees. However, excessive growth could be impractical, leading to the development of a specialized tentacle. This elongated appendage, equipped with sharp teeth, could allow the Deviodonts to grasp vegetation from the canopy, enabling them to maintain a lower-lying lifestyle while exploiting a unique food source. Furthermore, the Deviodonts' larger size might confer certain advantages, such as improved defense against predators and increased access to resources. However, larger body sizes also come with challenges, including higher energy requirements and slower reproductive rates. Thus, these creatures may be highly K-selective. We'll call this group the Divirudont. As the Divirudonts evolve, they will likely encounter competition with the Volumae. However, extinction is not the only potential outcome. The two species might instead engage in niche partitioning, a process where they specialize in different aspects of their environment to minimize competition. For example, the Volumae might focus on smaller plants that are lower to the ground, while the Divirudont may feed on the Excelifigro. By specializing in these distinct niches, both species could coexist without directly competing for the same resources. Now we can move to Nymphas to continue expanding the terrestrial ecosystems. As dead plant matter begins to build up on Nymphas, some Artanagile may become decomposers. Similarly to the Morategro, these plants may lose their yellow pigment. They may become smaller, with most of their bodies hidden underground. These root-like structures will probe for decaying matter. Once it finds its food, new sprouts will emerge from the roots. Once these plants are ready to reproduce, they will release their spores from their gas sacs. After this, the bud will die, however the larger organism will survive. We'll call these interesting plants the Saprotanagile. As the Artanagile begin to carpet the ground, some may evolve to grow taller. They may accomplish this with larger gas sacs, which lift them higher and can hold more weight. This adaptation would grant these Artanagile greater access to sunlight. Unlike plants on Earth, these organisms have no need of hard structural support. Thus these plants will have soft, spongy trunks. Interestingly, if one of these plants were to become detached from the ground, it may float slightly above the ground before eventually reattaching itself to the soil. We'll call these strange plants the Calamnifera. Unlike the creatures of Kaiora, the Pestanta and the Flesidola both made landfall around the same time. This would mean that the two clades have the opportunity to diversify at the same time. The Flesidola may quickly diversify into small adaptable creatures. Their small size means they don't weigh any appreciable amount. This suits their lack of bones, seeing as they can grow to extremely large sizes but are quite adept at smaller scales. Their small sizes and adaptive tendencies may allow them to achieve substantial levels of diversity. We'll call this group the heteromorphs. As they diversify, some may develop herbivorous tendencies. These herbivorous forms may have large muscular heads and tentacles to rip apart plant matter. Others may have long, slender bodies to snake around dense vegetation, giving them access to resources others may miss. As these herbivorous groups evolve, predatory heteromorphs will evolve to feed upon them. Some may evolve large bulky bodies with sharp teeth at the ends of their tentacles to pierce prey. Others may develop sharp, saw-like teeth to rip off chunks of flesh. Yet others may become scavengers feeding off of dead and decaying organic matter. Their topmost tentacle may become large and muscular with a large sharp tooth at the end, allowing them to pierce even the toughest of hides. Soon after they evolve, they will spread across the continent, forming the base of most all ecosystems on Nymphas. Other Flesidola may become medium-sized herbivores. Although their size would still be restricted, they may still be able to grow much larger than their ancestors. Their bottom tentacles may become broad rasping appendages used to grind plant matter before digestion. Their topmost tentacle may be used to pull plant matter towards the mouth. These creatures have differentiated their legs for different purposes. The first three pairs of legs are the primary locomotive limbs. They are larger and more muscular than the other limbs. The next two pairs of limbs play a smaller role in locomotion, mainly being used for stability and turning. The last pair of limbs have become analogous to the gonopods of Earth's arthropods. These limbs are used to hold onto the partner during reproduction. We'll call this group the Nitudola. The Pestanta may also be diversifying. The Pestanta, with their flexible skeletons, have the potential to surpass the Flesidola in both size and speed. This versatility opens up a world of possibilities for their ecological roles, from apex predators to large herbivores. While some Pestanta might embrace a herbivorous lifestyle, they'll likely need to develop some truly extraordinary adaptations. As bipeds, they may face limitations in reaching the massive sizes of Earth's megafauna. However, they could still dominate the herbivorous niches. Rather than simply lengthening their legs, which would compromise their balance, they might evolve a more radical solution, relocating their mouths to the tops of their heads. This adaptation would allow them to graze on vegetation without the need for a long neck or overly long legs. To support this new body plan, their legs might broaden, providing a sturdy foundation. Additionally, herbivorous Pestanta might develop specialized digestive systems to process tough plant matter. They may develop a sharp tooth similar in shape to a beak to slice through plant matter. They might also form symbiotic relationships with gut bacteria to help break down tougher molecules. We will call this strange group the Mosinerids. While the Mosinerids focus on herbivory, other Pestanta may assume the role of apex predators. They will require some form of weaponry to subdue their prey. Their tongues might lengthen, ending in a sharp spine. This tongue could be primarily used to capture smaller prey. Their primary killing weapon, however, lies in their feet. Their toeless feet may be equipped with a large claw. Their legs may also strengthen, granting them increased running and jumping power and enhancing the force of their kicks. They may employ their powerful legs in conjunction with their sharp claw to inflict severe injuries on their prey, either allowing it to bleed out or delivering the final blow. Their eyes may become more directional, with the top two pairs facing straight forward and the bottom two pairs facing more towards the sides. Their facets of eyes already provide them with exceptional depth perception. However, now, once they lock onto their prey, it may become nearly impossible to escape. They may primarily feed on creatures such as the Mosinerids, and supplement their diet with creatures such as the Nitudola and the heteromorphs. We will call these formidable predators the Lingurids. Perhaps some relatives of the Lingurids may take up the lifestyle of a detritivore. As a detritivore, its primary food source is derived from decaying organic matter. This lifestyle plays a crucial role in the ecosystem's nutrient cycle. These creatures exhibit adaptations that facilitate their decomposing lifestyle. Their bulkier legs and bidentate feet enable it to excavate roots and other subterranean organisms. Additionally, its tongue is used to probe for small animals. While they may occasionally display predatory behaviors, their primary sustenance is obtained from decomposing organisms. These creatures play a pivotal role in the ecosystem's nutrient cycle. As decomposers, they accelerate the breakdown of organic matter, releasing essential nutrients into the environment. We'll call these creatures the Canterid. Now, our terrestrial ecosystems are looking significantly fleshed out. We see the base of the food chains, the humble photosynthesizers. The energy they produce is then carried to the herbivores that feed on them. And in turn, the carnivores feed on the herbivores. Eventually, the carnivores will die, and their remains will return to the soil where it will be absorbed by those very same photosynthesizers, and the cycle will repeat. In the next episode, we will see how tectonic activities create distinct regions in which the climate changes from one extreme to the next. From scorching deserts to icy tundras, we will see how these creatures will adapt to claim these harsh environments as their own. A huge thank you to all the artists on Discord who made fan art for this episode. Your contributions to this project are invaluable. If you want to join the Discord to chat, make fan art, or even see creatures from the next episode early, then you can find the link in the description below. Thank you all so much for watching. Don't forget to subscribe, like, and share your thoughts on these incredible creatures. See you in the next episode.